Question number 8. Alan is collecting data to determine which of his radio-controlled model cars to enter the race. After his model car gets to a constant speed, he analyzes the distance the car travels as a function of time. So remember, as a function of is clue words. So car travels, distance the car travels. That is telling us those are our y values, which you see in the column. Distance is y. And then time, that would be x because it comes after that phrase as a function of. And you can see time is in the x column. And remember, if you forgot about those clue words as a function of, you know that time is always going to be your x value and the other unit of measurement is your y value. Okay, part A. What attribute of a linear function represents the speed of the car? Attributes like characteristics. In math, we have slope, y-intercept, x-intercept that are attributes and tell us things about our equation, our graph line, and all of those things. They want to know what represents the speed. Okay, so let's talk about speed. How do we measure the speed of our car that our parents drive or that Miss Love drives? Well, it's always miles per hour, right? Okay, so you know about speed. And remember, look, miles, distance, those would be your y values. Hours, those are talking about your x values because it's time. So look, it's talking about two changes. I have changes in my distance. I have changes in my time. But in this problem, our speed is not miles per hour. Our speed is really meters per second in the problem. Correct? Because if I look at the unit of measurement that's being used, seconds are my x values, or what I'm measuring my x numbers in, and meters is what we're measuring our distance in. So look, I have two changes to calculate speed. So there are two rates, and I know there are two rates because I have two units of measurement. So if I have two units of measurement for speed, that's telling me that there are two rates, which is telling me that I am talking about the attribute of slope. So speed is the attribute of slope. If you are talking about two different units of measurement, that means you have two different rates, and that means slope. And slope is two rates because remember, to find slope, we have to take the change in the y rates over the change in the x rates. Two different rates. Now we've got to determine the speed of each car. Okay, so let's talk about the blue car. So we're going to find the blue car first. So m equals y minus y over x minus x. So now I just have to pick two y values. So I'm just going to start with the first two. So I've got 13.8 minus 18.4. Fix my fraction bar here. And now I've got to pick x's. Since I use 13.8 first, I have to use 6 first and then 8. All right, let's do this. Now we're going to subtract. So I'm going to go to my calculator, and I've cleared my memory. So now I'm going to do 13.8 minus 18.4, and that's going to give me a rate of change for y of negative 4.6. Now I'm going to do the same thing for my x's. 6 minus 8, negative 2, and now I have to simplify my ratio. So I'm going to say negative 4.6 over negative 2 simplifies to 2.3 is my slope, and that's really 2.3 meters per second if I want to use my units of measurement. Okay, now I'm going to find the red car and do the same thing. I'm going to find two y values and two x values to plug in, and I'm just going to make it simple and pick the first two. So I'm going to do 7.5 minus 15, and I don't have to worry about that plus 0. It's not going to affect my answer. And now because I used 7.5 first, I have to use 3 and then 6, and now I'm going to grab my calculator because now it's just subtraction. 7.5 minus 15, negative 7.5, 3 minus 6, negative 3, and now I want to simplify my ratio. Negative 7.5 over negative 3, which is 2.5 meters per second. And now for the green car, same thing. We're going to find our slope, which means I need two y values to find the rate for y, and two x values to find the rate for x, because slope is two rates. And I'm going to use the first two, so I'm going to say 4.8 minus 12. And now I'm going to pick my x values. And since I used 4.8, I have to use 2 and then 5. All right, now I'm going to use my calculator. So I'm going to say 4.8 minus 12. That's going to give me negative 7.2. And 2 minus 5, negative 3. And now I'm going to simplify my ratio. Negative 7.2 over negative 3. And that gives me 2.4 meters per second. Now, if I want to do a does that make sense check, it should make sense that my slopes for all three cars are positive because we don't ever talk about cars having a negative speed, which means my graph lines should all be slanted in the puff positive direction to show that they are going up and the slope is positive. All right, so now part C. According to the data, which car should Alan enter in the race? Explain your reasoning. Well, let's think about it. If we're running a race, we want the fastest car. The fastest car has the highest speed. Fast car equals highest speed. Well, which car had the fastest speed? Which car was going the fastest according to its speed? The red car. The red car had a speed of 2.5 minutes per second. It's covering more distance in the same amount of time than the blue or the green car. So Alan should enter the red car. How do we know that? Because its speed was the highest. Because the red car had the highest speed. There we go. Boom. I answered the question, which car should he pick? And I explained it. It had the highest speed, aka it had the biggest slope.